All right, you got this. Let's learn some math. Hi there. So we are in the 1-41 intersection investigation for lesson 1.1.4. I am starting with this investigation by using TI emulator software. Now you can use a Texas Instrument. You can use Desmos as well, but most classrooms will be using the TI-84 to work on these kinds of problems. So the first thing I'm going to do is I'm going to go to my y equals, and I've got to type in my two functions. So f of x is 2x squared minus 5x plus 6. Notice I'm hitting this variable that has all of those little interesting labels on there, x, t, theta, and n. That's the first equation. So then I'm just going to scroll down to the second line, and I'm going to put in negative 2x. Now, a really important thing with Texas Instruments, you have to hit this button for the negative, not subtraction. So it's negative 2x squared and minus x plus 30. Now, just looking at these two functions, I know that they're both parabolas, they're both quadratics. This one is going to point downward because it has a negative in front of it, and this will point upward because it's positive. So we know we're going to have two quadratics intersecting. That means we're going to have two spots where they intersect. So let's take a look at the graph and see if it gives us everything that we need. So this is a graph in standard position, and where we can see the intersection of one part of the graph, we can't see all of it. So I'm going to start with zoom fit. So if I hit zoom and I scroll all the way down past zoom stat, it'll be zoom fit. You can just hit 0. Now this, we will come back to this, just so you know, because this is a really easy place to see where it intersects, but I've got to show you some things about how intersection works. But it's really not a good view of what values are actually hitting. So we're going to go back, because I actually know where the intersections are taking place. So we're going to go back to zoom standard, which is 6. And again, this is the original look that we looked at. So I'm going to change my window. And I know I need more positive x, or a positive y. So I'm just scrolling down here to the y. And I'm just going to put 50. Let's start with 30. Okay, so I'm going to do 30. And then I'm going to change the scale, because sometimes when you have a scale that big, there's like lots of, I'm just going to put, let's put 2. Because you'll get lots of tick marks and then it's a little distracting. So I'm going to hit enter. Let's go to the graph. Awesome. So both intersections are taking place. My y is on a scale of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Looks like negative 2 and 24. And then over here, it looks like 3, and then 2, 4, 6, 8. This looks like it's in between, so it looks like it could be a 9. Now, I was going to go back to that other one, but this particular graph is perfect also for using this next tool. So the first thing I'm going to do is I'm going to go look at my tables. All right, so second tables. All right, they have all of these great values in here. So I'm going to go to the x value and scroll down. I wonder if I can scroll up. Let's see if I can go to the negatives. Of course I can. Well, look at here. We have negative 2, 24, 24. That works perfectly on the table. So that estimate was good. And you can tell that because this is this is f of x, this is g of x. You come here and you know that this is the intersection because they both share the same intersection point, the same coordinate. Then we go down to what we estimated as 3 and 9. That works perfectly. Okay. Now we're going to go back to the graph, and I'm going to show you an intersection tool, because sometimes it's really tough to tell what the intersection is because of the large number of it. So we're going to use this tool. You go to second calc. So it's second trace button, and you'll see the calc above it. We're calculating the intersection. And down here it says intersect at 5. So we're going to hit 5. Our cursor shows up here, and we need to get it up here. We're going to do this side first. So let's go up. All right. So we've got our first curve. I'm going to go here right where it's intersected. So I'm going to hit enter. Then it says second curve. I'm going to hit enter again. And then it's ready for a guess. So it's actually in that area trying to figure it out for us. And it gets us to -2 and 24, which is exactly what we wanted to find, which was also what was in the table. So we're doing this. First we showed it in the tables. Now we're going to show it in the graph. So we're going to do second calc again, because we're going to find the intersection of the other side of the graph. So I'm going to hit 5, and I'm going to scroll all the way around. Okay, very good. All right, and I'm on where the intersection happens. So I've got first curve, second curve, and if you notice, they're pretty close to, if I was rounding, it'd be 3 and 9. And then it's going to come to this where it says my guess, and it's going to give me 3 and 9. So that's the other point. So that's all the information on how to do it on the calculator. The other question that they wanted us to look at was, how do we do these with equations? So we're going to go to another slide, and we're going to talk about those equations. All right, so you saw that we solved on the TI emulator software, so on the Texas Instruments calculator, we solved how to find the intersection point using tables, but also the intersect activity that you can use on the TI. Now, I'm going to go ahead and write the solutions that we came up with, because we're also going to prove them graphically, or through an equation. So this is 3-9, okay? And then this one was -2, 24. All right. So the other thing I'm going to start with, just to make this easier for you, when we are looking for the intersection of two different graphs, that is also considered the solution for our systems of equations. So f of x is like a y. And if you remember when we put it in the Texas Instrument calculator, it was a y1 for that one, and then y2 for the second one. So I'm going to rewrite these as y. Oh, let me change the color of that. Sorry about that. It's hard to see. This will be much better. Okay, so let me change the f of x to a y, and then the g of x to a y. So what we're going to do right now is we're going to set, because they both equal y, and we are looking for an intersection point, we can set these equal to each other. So I'm going to set 2x squared equal to -2x squared minus x plus 30. Now, when we're solving for quadratics, and I'm not exactly sure how much experience you've had with quadratics, so I'm hoping this is a review for some, but it may not be. You are looking for two solutions, and we actually have two solutions that we are aware of just from what we did on the calculator and on the tables on that calculator. So setting them equal to each other, my goal is to get everything off onto one side, setting it equal to 0. Then we're going to factor the equation and come up with the two solutions and check our work. So the first thing I'm going to do is I'm going to move everything from this side over here. Okay, so in doing that, I'm going to add 2x squared. So that changes this to 4x squared. I'm going to add an x, and that means this will now be -4x. And then I'm going to subtract 30. So that's going to give me a -24, and then it all equals 0. The nice thing about this that makes the factoring easy on this is we have something common to each term. I can divide out a 4 to make my life easier. So I'm going to divide a 4 from all of these. That changes this to an x squared, and this to a -x, and this to a -6. Okay? And if you remember, I like to use the diamond method, so let me draw that. So with this diamond method, if you remember, we put AC, ooh, that's really thick, and B down here. Let me change the width of my pen, much better. Okay, AC in this case is going to be, so A equals 1, B equals -1, and C equals negative 6. So that means A times C is going to be a negative 6, and B is going to be a negative 1. So I have to come up with two numbers that multiply to a negative 6 and add up to a negative 1. That is negative 3 and 2. So I can come over here and factor this equation. I'll put the factors down here to x minus 3 and x plus 2. Now, that means that this is x equals 3 because that's what makes that set of parentheses 0. And this is x equals negative 2 because that's what makes that set of parentheses equal 0, which is actually a good thing because of what we have here. We want negative 2 and we want 3. But now we need to prove with our equations really quickly whether or not those fit. Okay, so let's do that. I'm going to go ahead and just put the work on here so you can see it and verify that we can do that. So as you can see, I am now putting the work in place here so you can see that we have checked it. This works. Because we plugged in 3 for every x value and solved it down where it equals 9 equals 9. And then the same thing here. This also works. We put a negative 2 in all the different spots to check the work and got down to 24 equals 24, which means the answers are correct. So hopefully this helps you understand a little bit better about how to solve using equations, the graphs, and the tables. And now we're moving on. This particular problem is 1-45A. The last slides took care of 3 problems at once. This will actually take a couple slides to talk about the 2 different problems. And the reason for that is they kind of come up with different looks and different equations. Now, when I look at this one, it says Rihanna says she can draw different functions that have the same x-intercepts and the same domain and range. Her teammates say, no, that's impossible. But Rihanna insists it's possible if we just try to sketch the graph. So we're going to come up with the equation that helps you sketch the graph. And that's because we're going to use, I want to make sure I have the right color here. Very good. We're going to use these x-intercepts to build an equation. And that's because we've been using the zero product property, and that helps us go in reverse. And what zero product property helps us find the zeros on the x-axis, we can go backwards with it too. So I need to write an equation that has negative 5 makes the equation 0, or the expression 0. So I'm going to say x plus 5. If I put negative 5 in here, this would be, so if I put negative 5 in, okay, so that's why I'm doing that. I'm thinking the opposite of what I have for my intercepts. So let me go ahead and erase that. Gotta get a bigger eraser, hang on. Okay. So we're going to do the same thing with the other 2. So we're going to have, I'm going to have x minus 2, because if I put a 2 in there, it'll equal 0. Then I'm going to have x minus 6. Again, if I put a 6 in there, it's going to equal 0. So now what I'm going to do is I'm just going to multiply all 3 of them by each other, and I'm going to end up with a cubic equation because I have 3 x's. So I'm going to end up with an x to the 3rd. So I'm first going to use these 2. I'm going to multiply these 2. So I'm going to multiply the first terms. That's x squared. The outer terms, that's minus 2x. The inner terms, that's plus 5x. And the last 2. You could use the box method as well if that's what you're comfortable with. This takes me, and I still have x minus 6 here, but I'm going to do that in just a moment. This takes me, when I combine like terms, to x squared plus 3x minus 10. And then I have to multiply by x minus 6. Now, I'm going to show you a little bit different way of doing that. Let me rewrite that up here. Okay. Here's a way to do this where you don't have to spread out your equation all the way across the page. So first I'm going to take this term and I'm going to multiply it by everything in here. So x squared times x is x to the 3rd. Then x squared times a negative 6 is minus 6x squared. Then I'm going to come here and I'm going to multiply this term by everything in here. And that gives me 3x times x. So I'm going to put that under here because they're like terms. So 3x squared. Then I'm going to do 3x times negative 6, which is minus 18x. Okay. Then I'm going to go get everything for negative 10, and I'm going to multiply it by this. So that gives me negative 10 times x, which is a negative 10x, which I'm going to put under its like term. And then negative 10 times negative 6 is a positive 60. Then I'm just going to add up the columns. This will be the equation that I take into the Desmos activity that you're going to watch next. So here we go, on to that. So we just got done talking about how we came to this equation, which I have put into Desmos right now. And we have a few other questions that we need to answer with regard to this. So I also want you to notice I did put a picture in here. And you have to play with, when you change the scale, you have to play with the width and height. You can actually just click on this little plus and it lets you load an image. And then you just have to figure out where you want the center of that image to be. And it turns out it's kind of a fun little thing. So if you want to send your teacher a graph or something like that with a funny image in it, it's actually entertaining to do. And teachers love when students do things like that. So I'm going to change the center on this, by the way, because we're going to need that negative 5 and it's kind of getting in the way. So let's see here. And negative, negative 10. Oops, that was weird. Okay, good enough. All right. So now what we're going to do is I want to, first of all, you see the scale's a little weird here. But in order to see this graph, I need to do something with the x values. And this is kind of what you would do to play with it. I wanted to at least limit it some, so I picked a negative 10 to 10. And so that way it changed the scale a little bit. Now you'll see the scale here is 10 for the y and 1 for the x. And that's because of the way this graph looks. So let's go ahead and unmute this and show you this graph. And you can see here, it hits at negative 5, and it hits at 2, and it hits at 6. And those are the 3 different values that we were given for the x-intercepts. All right. Now, the question is, first of all, it wants the domain set. So we're going to come in here, and we're going to, this is the way you do this with Desmos. You do curly bracket, and then you set it as negative 5. And let me get my equation on my calculator so you can hear it. Negative 5 is less than or equal to x, which is less than or equal to 7. Because what that does is it cuts off parts of the graph. And then you hit the curly bracket again, which is on your keyboard. Then you do another curly bracket. And this is how you use to set the domain and range. So now we're setting the range. So negative 4, and that is less than or equal to y, which is less than or equal to 10. All right, and we'll be copying and pasting those in a moment, but let's take a look at this graph now. Okay. All right, get rid of that keyboard. Now, see, this is interesting. These are the restrictions, and so you don't see everything else because it's asked us to set those domain and range restrictions. Let's see if we can scroll over here a little bit so you can see better. So this was part of the problem. All right, now, another way, wanted to know, how do we know if there's more functions? Well, there's a couple ways you could do this. You can multiply the coefficient of each one of those in that equation by a different number. So why don't we just double everything right now? So we're going to go y equals, and I'm going to say 2x to the third. Let's get that equation up here again. 2x to the third minus 6x squared minus 56x plus 120. Okay, see what happens there? they still have the same solutions. They still have the same x-intercepts. So let's go up here. I want to make sure I can get all of this copied. So I'm going to copy all of this. Okay, let me copy it. All right. Control C, then Control V. And you see what happens. It limits it again, even though the angles are a little different, all of the x-intercepts are the same. Okay, that was doubling it. Now, how about if we go smaller than that, okay? And we go with one third, or one third of that, okay? So we're gonna go y equals, and it's gonna be x, I'm just gonna do 1/3, okay? X cubed. Okay, then minus, so minus x squared, because we're doing it off the original, if you're wondering what I'm doing. X squared minus 28 divided by 3, which I'm going to leave in fraction form, x, and then plus 20. Okay. Here's another graph. Still a cubic equation. Now let's do Control V here, and it limits the domain and range. So you still have the same solutions, but you also still have 3 different functions. So there is an infinite number of solutions for this particular graph, or this particular set of intercepts. And at this point, I would say most, if not all, are cubic equations in order to get all 3. There could be some other equations that do that, but this is the easiest way to find multiple functions for the particular graph. So hope that helps. That adds to what you just learned when we went through setting up this original equation of y equals x to the third and so on. Okay, that ends that for now. So we just finished 145A, and so with 145B, we'll have the same setup. I'll go over this particular set of x-intercepts, and then we will plot that on Desmos, and you can see if it's possible to have more than one function and what they look like. So here we go. With the zero product property, just like we did before on the last one, I'm going to go ahead and I'm going to write out the x minus 4, so it's negative 4, 0, so it'll be x plus 4. Just getting the right pen here. Hang on just a moment. Okay, here we go. So x plus 4, because if I put a negative 4 in that, it would equal 0. And then x minus 2. And on this one, I'll go ahead and use the box method because that's what some of you are doing, but you just multiply this out. So if I create my box, okay, I put an x and a positive 4 and an x and a minus 2. Then I just multiply x times x. I multiply x times 4. I multiply x times negative 2. And I multiply negative 2 times 4, which is negative 8. So then I just combine like terms, x squared. I add those two together, so that's plus 2x minus 8. And that's the equation that we will take into Desmos to work on that equation and see if there's other functions with those range restrictions they're giving us. So here we go. I do want to add one little thing here. I'm noticing this says y is less than or equal to negative 8. The actual one is y is greater than or equal to negative 8. So we will we'll adjust that when we get into Desmos. Hey there, so no fancy picture on this one, but this one won't take very long either. So the equation that we came up with was y equals x squared plus 2x minus 8. So you see that graphed here. But now we need to put in the restrictions. So remember, it's curly brackets, and then this one is y is greater than or equal to negative 8. And don't forget to put the curly brackets on it. Now, this is an easier graph to see and move around in Desmos, so you can check it out. If you look here, it's just this tip down here that they're getting rid of. So they're just from domain of 0 to negative 2, you don't have any graph points. So, and that's because of the restriction on this one. So now what we're going to do is we're going to do the same thing we did the last time when we added other equations. So this time let's just double everything. So y equals, and it's going to be 2x squared plus 4x minus 16. And I'm just going to go ahead and copy and paste these restrictions on the range and the same thing. So look at that. That's another function, and this passes the vertical line test, so it's still a function. Every x has one y value, so it's not like anything strange. It's just they've restricted the range. So let's do one other. Okay, let's try cutting this in half. So y equals, and we'll just say, because we can do this too, 0.5 x squared plus 2x and minus 8. And again, there's the full thing. What did I do wrong? I did something wrong. 0.5 x squared plus... Oh wait, it's supposed to be plus x. I was doing something wrong here. It's not right. And then minus 4. I was doing the wrong... was comparing the wrong equation. All right, so we're good. Now that we fixed that, at least you know I'm human and I make mistakes. Yeah, so anyway, here we go. I'm going to go ahead and paste the restriction, same place. But the difference on this one is this doesn't even go down to the where the restriction is. So it's still a function that has the same domain. It still has the same range too. It just happens to not go down to -8, so it's totally fine. Now that will end our discussion about 145b.